This is a video solution for the Tamagotchi task. This task has two parts. The first part is to write a specification for a class modeling a Tamagotchi, and the second part is to implement that specification by writing a class named Tamagotchi that conforms to our specification that we've written. Let's start by writing this specification. And the purpose of this specification is to set out the ways of interacting with the class and some details about the internal details of the class, such as what fields it's going to have and what those represent. So let's start by writing this is a Tamagotchi specification. Let's start by listing the ways that we want to be able to interact with the Tamagotchi. We want to be able to, for example, feed the Tamagotchi. We want to be able to take it for a walk. Maybe we want to be able to clean it. And maybe we want to be able to play with it or pet it. So I think that's enough ways of interacting with the Tamagotchi that are kind of the obvious ones. There are a couple more that we need to include according to this, the instructions for the task. One of those is to get the current mood. So get the Tamagotchi's current mood. And we also want to be able to pass time. So these are our ways of interacting with the Tamagotchi. This is not enough detail for this to be a specification though, because I haven't said what these methods should do or what should happen when I interact with a Tamagotchi in this way. So for example, I could say when you feed the Tamagotchi, it gets less hungry. When you take a Tamagotchi for a walk, I could say it gets happier and more tired. When I clean the Tamagotchi, it gets cleaner. If I pet the Tamagotchi, then it should get happier. So this is adding a bit more detail, but I should probably specify how the hungriness of the Tamagotchi is represented, and we're also representing things like how happy the Tamagotchi is, how tired the Tamagotchi is, and how clean the Tamagotchi is. So those are all going to be things that the Tamagotchi object needs to remember. Those are going to be the fields of the class that we're writing. So let's start specifying the internal state of the Tamagotchi. How are those things like hungriness, happiness, cleanliness represented as fields? So we can say a Tamagotchi has hungriness, happiness, cleanliness, and we've got happiness already. There's tiredness in here as well, because when we take the Tamagotchi for a walk, it should get more tired. So, and tiredness. So it says actually in the instructions that these should be represented as numbers within the range 1 to 10. So let's say these are numbers or integers in the range 0 to 10. So I don't need to say numbers because an integer is a kind of number. So this is doing well so far, but we can be more specific. So for example, when we feed the Tamagotchi, how much less hungry should it get? So let's specify that it gets, for example, 5 less hungry. So it gets less hungry by 5. Or its hungriness goes down by 5. When we take the Tamagotchi for a walk, it should get happier. So let's just choose some arbitrary numbers here. Let's say it gets happier by 3 and more tired by 2. When we clean the Tamagotchi, it gets cleaner. So let's specify that it just goes up to 10. Just we do a thorough job cleaning the Tamagotchi, so it's perfectly clean after we've cleaned it. When we pet the Tamagotchi, then let's specify that this goes up by, let's say, 5 again. So its happiness increases by 5. We should specify what these other two methods do. So when I get the Tamagotchi's current mood, what state could the Tamagotchi be in? What mood could it be in? Well, if the Tamagotchi has a tiredness rating, then maybe the Tamagotchi should be able to be asleep. So let's say that if the tiredness is 10, then the Tamagotchi is asleep. Otherwise, we might say if tiredness is over 8, or at least 8, the Tamagotchi is tired. And let's put these in double quotes, because here we're specifying the mood of the Tamagotchi. So the mood would be asleep or tired. We could also say if the Tamagotchi is hungry, then we can return that it's hungry. So if the hungriness is at least, let's say, 7, then the Tamagotchi is hungry. We can also say whether the Tamagotchi is dirty or not. So if cleanliness is less than 3, let's say, then the Tamagotchi is dirty. And otherwise we can return something like happy or sad or something like that. So if the happiness is at least, let's choose the 7 as an arbitrary number, then the Tamagotchi is happy. If the happiness is at least 4, then we can say the Tamagotchi isn't sad, so let's just say it is okay or something like that. And then otherwise the Tamagotchi is sad. So this is a fair few details here, but we've specified exactly how to work out the mood of the Tamagotchi, and then when it comes to implement this, we'll know exactly what the method needs to do. The final method here, to pass time, this should model what happens when we leave the Tamagotchi alone for a short while. So if we imagine this model being run on a real Tamagotchi device, then this method would be whatever happens to update the Tamagotchi's state maybe every 10 minutes or so. So what should happen when time passes? Well, the Tamagotchi has hungriness, happiness, cleanliness, and tiredness. So when time passes, the Tamagotchi should get hungrier. So the Tamagotchi, let's say the hungriness goes up by 1, just automatically. When time passes, the Tamagotchi gets dirtier, so we can say that cleanliness goes down by 1. And also, as time passes, the tiredness goes up, so the tiredness goes up by 1 because the Tamagotchi is getting more tired as time goes on. But of course, since we've said that when the tiredness is 10, then the Tamagotchi will sleep, we can say unless the tiredness is 10, in which case it's asleep, so maybe it should wake up. So in which case the Tamagotchi wakes up with a tiredness of, let's say, 0. So when it wakes up, it's completely not tired. And we should say what happens to the happiness. So the happiness is a bit more complicated, or at least it would make sense for it to be a bit more complicated, because the happiness of the Tamagotchi should depend on things like how hungry it is, how tired it is, and so on. So if the Tamagotchi is hungry and it's not been fed, then we should make the Tamagotchi less happy. So if the Tamagotchi's hungriness is, let's say, at least 7, in that case it's hungry. So we're going to decrease happiness by 1. And we can also say if it's dirty, so if it's very unclean, so if the Tamagotchi's cleanliness is what we called it, is less than 3, then the Tamagotchi is dirty, and the Tamagotchi doesn't like being dirty, so we can reduce the happiness by 1 as well. So if it's less than 3, decrease the happiness by 1 again. And I think that's probably good enough for passing time here. We've kept track of what happens to its hungriness, cleanliness, tiredness, and happiness. So this should be sufficient to model what's going on with the Tamagotchi. There are a few details that we might want to add here. So we should say whether any of these methods take parameters. And actually none of these do. None of these methods need to take any parameters because we've specified exactly what they're going to do. There's no variables that control what's going to happen other than the fields that the Tamagotchi already has. So there's no need for me to take parameters for these methods. So these are the ways of interacting with a Tamagotchi. These are the methods. So you can interact with the Tamagotchi by doing one of these things, and then we can specify that none of these methods take a parameter. And most of these methods don't need to return anything either, because they just update the Tamagotchi's internal state. But when we're getting the Tamagotchi's current mood, we should say that that mood is represented as a string. So we've said here that asleep is a mood, tired is a mood, hungry is a mood, and so on. And those can be represented as strings in our model. There's another detail that we need to get right here, which is that we've said that these integers are in the range 0 to 10, and some of these methods, at least as specified, might be able to move those numbers outside the range 0 to 10. For example, if we feed the Tamagotchi, then its hungriness goes down by 5. If its hungriness was less than 5, then subtracting 5 would take it to a negative number, which is outside the range of valid numbers for the hungriness. So we should also specify that if any of these methods reduce one of the integers to below 0, then that integer is set to just 0. So it bottoms out at 0. We can do the same with 10. For example, when we make the Tamagotchi happier by 3, if its happiness was 8 and we add 3, that would go to 11. So to keep it in the valid range of 0 to 10, we can say if any of these methods raise one of the integers to above 10, then that integer is set to 10. So it just maxes out at 10. And I think this is sufficient to model exactly how we want the Tamagotchi to behave. You'll notice here that I've made a lot of decisions, so a lot of this is just arbitrary. I've just made up what I think a Tamagotchi should do, and I've tried to keep it sensible. But all of what I've written down here is basically choices. So I've chosen that feeding, walking, cleaning, and petting the Tamagotchi are the 4 ways of interacting with it that aren't included in the instructions. And obviously I've got these other 2 which were included in the instructions, but the other 4 were just my choices. And I've chosen arbitrarily what should happen to these numbers. And also I've chosen arbitrarily what these numbers even mean. So your specification could look very different to this, and this is just purely for example. Now that I've written this specification, let's move on to the second half of this task, which is to implement the Tamagotchi class. So I'm going to use this specification that I've written in order to write a class named Tamagotchi, and this specification should tell me exactly how the Tamagotchi should behave when you call its methods. So I'm going to start by moving this over here, and then we can create a class named Tamagotchi in BlueJ. This class should be public, and the methods that we've specified should be public as well. Let's start by getting the signatures of these methods correct. So we can feed the Tamagotchi. Feeding is a verb, that's an action, so I don't need any extra word like get feed or something like that. That wouldn't make sense. We'll just call this method feed. So this method doesn't need to return anything, and it doesn't need to take any parameters, so it can be void and have no parameters here. And I'm going to write a comment to say to do. We haven't finished this method yet. We can take the Tamagotchi for a walk, so I'm going to call this method walk. And again, I'm going to say to do. This method is not done yet. Again, this walking needs no parameters. There's nothing about its behavior that depends on any other inputs. And it doesn't need to return anything, it just changes the Tamagotchi's internal state. That's its 4 numbers. We can clean the Tamagotchi, so let's have a method called public void clean. And again, I'm going to write to do here to remind myself that I need to finish this method later. We can pet the Tamagotchi, so let's say public void pet. We can get the Tamagotchi's mood, so I'm going to call this method getMood, and it returns a string. And I don't need to provide any parameters here. And then finally there should be a method to pass the time, so I'm going to have a method that passes time. Again, I don't need to provide any parameters here, and it doesn't need to return anything, so I'm just going to call this pass time and write a to do comment here as well. So now that I've got the signatures of these methods correct, I'm going to start implementing these methods. When I feed the Tamagotchi, for example, then it should get less hungry. So I can say hungriness minus equals 5. That should reduce the hungriness by 5. But I also need to remember that if this goes down below 0, then I should set it to 0. So let's write if hungriness is less than 0, then we're going to set hungriness to 0 directly. And I've got an error here because we don't have a field named hungriness, so let's declare that field. And let's say at the start, when you've created your Tamagotchi, it's not hungry at all. So we'll start off with a value of 0 here. Let's implement the walk method. When I take the Tamagotchi for a walk, it should get happier by 3 and more tired by 2. So I'm going to increase the happiness by 3 and increase the tiredness by 2. Now both of these could go over 10, so I want to keep them within bounds. I want to keep them within the range 0 to 10. So if the happiness is over 10, we're just going to set happiness to 10. And if the tiredness is over 10, we're just going to set tiredness to 10, so it maxes out at 10. Again, I've got some errors here. We can't find variable happiness, can't find variable tiredness. That means we need to declare these fields. These are part of the internal state of the Tamagotchi. The Tamagotchi has a happiness level and a tiredness level. And we'll say that the Tamagotchi is medium happy, let's say 5, in the middle of the range when we create the Tamagotchi, and its tiredness can be 0 because it's not tired at all when we've just got it. So now those errors are going to go away. I've got another error here which is just a typo, so I'm going to correct this spelling mistake here. That should be happiness with 2 P's. Let's move on to the clean method. So when we clean the Tamagotchi, it becomes perfectly clean, so we're going to change its cleanliness to 10, and that's it. That's all I need to do in this method. I'm going to set the cleanliness to 10, and because I'm not adding or subtracting, this is definitely within the range 0 to 10, so I don't need any if check here. Again, to solve this error, I'm going to define a field called cleanliness, and this will be private again. And we're going to say that when you get your Tamagotchi in the first place, it's perfectly clean, so it starts off with a cleanliness of 10. The pet method should make the Tamagotchi happier by 5, so this is going to increase the happiness by 5, plus equals 5. Again, I need to check that I'm not taking this over 10. I've already got this code here that will max it out at 10, so I'm going to reuse that. That's good enough for now. We need a method to get the mood and a method to pass the time, so these are the more complicated methods. So when we get the Tamagotchi's current mood, we're just going to go down this list one by one, checking these conditions with a lot of conditional statements like if, else if, else if, else if, else if. And then finally we've got an else for the otherwise. So to get the mood, if the tiredness is 10, then we're going to return that the Tamagotchi is asleep. That's what the specification says we should do. Otherwise, if the tiredness is at least 8, we're going to say that the Tamagotchi is tired. Otherwise, if the hungriness is at least 7, so hungriness greater than or equal to 7, we're going to say that the Tamagotchi is hungry. If the cleanliness is less than 3, then the Tamagotchi is dirty, so we're going to return dirty. If the happiness is at least 7, we're going to return happy, because the mood is happy. Otherwise, if the happiness is at least 4, we're going to return okay. And otherwise, we know that the happiness is less than 4, so we're going to return sad. So this is a complete implementation of the getMood method according to our specification. This behaves exactly the way that the specification says it should behave. Now let's write the passTime method. In the specification, we've said what should happen to each of these 4 numbers as time passes. So we'll start by increasing the hungriness by 1. We should decrease the cleanliness by 1. The tiredness should go up by 1 unless it's already 10. So in this case I need an if statement. So if the tiredness is 10, then the Tamagotchi is asleep, so it should wake up. We're going to set the tiredness to 0 here, and otherwise we're going to increase the tiredness by 1. Then the hungriness has a chance to affect the happiness. So if the Tamagotchi is hungry, we'll decrease its happiness. So if the hungriness is at least 7, we're going to reduce the happiness by 1. And if the cleanliness is less than 3, then the Tamagotchi is dirty and it doesn't like being dirty, so we're going to decrease its happiness by 1. So now that we've done all of this, we need to make sure that those fields are staying in the range of 0 to 10. So this hungriness plus plus here could take the hungriness out of bounds. So let's check if the hungriness has gone over 10, then we need to set the hungriness to 10. This cleanliness minus minus could take it below 0. So if the cleanliness is below 0, then we're going to set it to 0, so it bottoms out at 0. This tiredness we actually don't need to check because we've already checked that if it's 10 we'll reset it to 0. So this plus plus will only happen if the tiredness is less than 10. We knew that it was at most 10 before, so it can't be more than 10. And if it is 10, then we'll be setting it to 0. So this must be less than 10 before we increase it. So I don't need to check that it's gone over 10. In this case, the happiness could go down by up to 2 though, so let's check that the happiness hasn't gone below 0. If it has, then we need to reset it to the minimum of 0. So that's a complete implementation of the past time method according to this specification, and that's the last method I need to implement. There is some more I could do with this, so obviously I'd want to test my class. I'm not going to do that in this video, just to save time. But you should test this class by creating a Tamagotchi object and calling its methods, and when you want to see its mood, you'll need to call the getMood method. If you want to pass time, you call the passTime method, and so on. You'll notice that this solution doesn't have any kind of keyboard input. There's no loop that asks the user to enter a command and then calls one of these methods depending on that command. That loop doesn't exist. There's no main program for this class, it's just a model, and the specification only asked us to write a model. The specification didn't ask for a full program involving keyboard inputs or a loop that keeps performing some of these operations. So therefore we didn't write one. That's a common theme when we're modeling. We don't want to think about writing a full program. We just want a class that behaves the way that this entity should behave. So this class simulates the Tamagotchi, but it doesn't implement a complete program for playing with the Tamagotchi. So just as a reminder, this specification is very arbitrary. I made it up as I went along. I made a lot of decisions here which will be different to the decisions you'll have made. I made decisions about what fields my Tamagotchi should have, what they should mean, the ways of interacting with the Tamagotchi. I just made these up, and I just decided arbitrarily what these numbers should be, what parts of the state should be affected, and how. I arbitrarily decided that these would be the moods, and this would be how the mood is decided, and so on. So your specification could be very different to mine, and your solution will therefore be very different to mine. But what matters is that the specification is enough for me to write this class without having to make anything up while I'm writing the class. I've made all of my decisions in the specification. There's nothing left unspecified. And also when writing the class that I have conformed with that specification. So these methods only do something if the specification says they should do it. Let's end the video there.